Morning, friends. So today's game I named it as Toss Steal Tail. Toss Steal Tail. So I'm tossing a coin. Tail has come up. Head, tail, head, tail. So I'm counting the number of consecutive heads. So this is one head. Then tail came. So it's a run of one head. So I'm trying to toss as many number of consecutive heads I can. So till now I have tossed 4 consecutive heads and it took 6 tosses, and this is the exact time when the 4 consecutive head happens. So this game goes on like this. Let me see if I can cross 4. So I tossed 5 consecutive heads at 12:30:04 p.m. So and it took 28 tosses. There have been 18 runs, and I expect one run of 5 consecutive heads in 32 tosses. The probability of getting 5 consecutive heads is 1 by 32. So in 32 heads, 32 tosses, I expect one run of 5 consecutive heads. So this game goes on like this. Let me see. I'm trying to there is an option of 20 consecutive heads, but this will never happen. This is a rare probability. This is a probability. This event has I mean getting 20 consecutive heads. This event has the probability 1 by 2 or 20, which is very low. So this is unlikely to happen. So one goes on tossing the coin and trying to and try to see how many consecutive heads appear. So 6 consecutive heads, then one tail happened in 74 tosses. I don't think I'll be able to progress any further. 7 happens sometimes. So instead of ticking manually, I created a button of automated run. So let me run that. So automated run. Let me try that. So one toss is complete and it's a tail. 2 tosses, 2 tails, no head yet. 4 tosses, and there have been 2 consecutive heads that happened in toss 4. So now it's running. There have been 4 consecutive. There have been 2 consecutive heads, and the number of tosses is 4. So now I have got 3 consecutive heads in 14 tosses. So a run of 6 consecutive heads happened in 43rd toss. Let me see how far I can progress. 6 consecutive heads. Now I have got 9 consecutive heads at the time 12:32 47 p.m. 9 consecutive heads, and I got it in 193 tosses. It was expected to happen by 512 tosses, which is 2 power 9. But it happened in 193 tosses, and there have been 133 such runs of consecutive heads. Now the loop is of 1000 tosses, 2 power 10. 9 have been the latest maximum run of consecutive heads. So to have 10 consecutive heads, I expect it to happen in within 2 power 10 tosses, which is 1024. Now tosses are going on. 1000 tosses will complete soon. Okay, and it didn't proceed. Still, I am having a maximum of 9 consecutive heads. Let me run it one more time. I could reach up to 18. That happened by chance. I never expect to have a run of 18 consecutive heads, but it happened. Let me see how far I can go today. 1,000 tosses are happening. 9 consecutive heads appeared in 193rd toss. 193rd tosses. There have been 523 runs, that is 523 tails, you can say 523 tails. That is 523 runs of consecutive heads. And the expected number of tosses to get 9 consecutive heads is 512, but I got it in 193 tosses, so I'm a bit lucky. 1,000 tosses are happening. Let me see if I can cross 9 today. Okay, I got a run of 10 consecutive heads. That happened in 1369th toss. And the number of tosses so far is 2048. And the next run will be of 2048 tosses. Shall I try it? I have time. I have only 7 minutes. I have covered only 7 minutes. So I'll run a loop of 2000 tosses. Let me see how far I can go. 10 tosses, 10 consecutive heads are supposed to appear in 2 power 10 tosses, which is 1024. So 11 consecutive heads are expected to appear in 2048 tosses. So that's the length of the loop now. So it's running 2000 tosses. Toss till tail. Go on tossing till a tail occurs. And you try and you count the number of consecutive heads. I have got a run of 10 consecutive heads in 1369 tosses, and that had the probability of 1 by 2 power 10. And if you consider the 11th, if you consider the next tail to end the run, the probability is 1 by 2 power 11, which is a very low probability. These are all rare events, but these are happening. And this is happening only when I do an automated run. Otherwise, clicking manually is a problem. So I'm running 2000 tosses. 10 consecutive heads appeared in 1369 tosses at the time 12 p.m. 12:34 32 p.m. This is the latest timestamp of the maximum number of consecutive heads so far. It will take a bit time, but I'll wait. I have passed only 9 minutes. Statistically speaking, the total number of tosses, total number of consecutive heads follow a negative binomial distribution. The probability of having a run of n heads is 2 power n minus 1, n heads, and the last toss should be a tail. So the probability is 1 by 2, 2 power n minus 1. And if you sum it from 0 to infinity, the total probability is 1. I forgot the mean and variance of the negative binomial distribution, but it's a statistical distribution, discrete distribution, and I'm just visualizing the distribution, the progress. Let me see what happens in 2000 tosses. So this curve is the exponential curve. It's a curve like 2 power n. Only the last jump comes out significantly. The jumps before the jumps preceding the last jumps look very small. So once I studied the rise of gold price in India, 10-gram gold, the price starting from I think 1920, and I found it is increasing exponentially. The latest jump is always the significant one. It's a sort of exponential curve. 12 minutes, 2000 tosses are happening. Toss, tail, tail. Sometimes this is called waiting game. Waiting game. Your waiting time increases exponentially and you are bound to lose the track of it. So I have got 13 consecutive heads that happened in 3988th toss. I have got 13 consecutive heads, and the next loop is going to be a loop of 16,000 toss. I am not going to venture there. There have been 2000 tails. I have got 13 consecutive heads, and that happened at 12:41:20 p.m. So fathoming the progress is of an exponential process is difficult. You don't know how long you are going to wait for the next time. Okay, so I'd stop here. Thank you.